All right, so let's do our 4 examples. So example 1 says we want to find a particular solution. Now remember, the difference between particular and general solution is that general solution has includes just the C, while particular solution has the C figured out by using an initial condition. So we have that initial condition, so we're going to need that for our particular solution. So our first step we're going to do is separating our variables. So let's multiply both sides by dx. So we get dy is equal to y squared dx. And we want to get the y squared out of there, so I'm going to divide by y squared, which leaves us with, and I'm going to rewrite it as 1 over y squared dy is equal to just dx. Okay. I'm going to need to then, next step is to take the integral. Okay, so let's see if we can rearrange the left side. We can rearrange it by making y to the negative 2 power, bringing it to the numerator. Fantastic. So now we know that when we take the integral, we're going to increase the power by 1, and we're going to do 1 over whatever that power is now. Plus c1 is equal to, it's just a constant. So, if there's a 1 here, right, then it would just turn into x dx. Oops, not dx, sorry. X plus c2. All right, so we can move the constant over and get negative y to negative first power is equal to x plus some new constant. And so what I can do is I found my general solution. So this is my general solution. But I need a particular solution by plugging in this guy. So let's plug this in now. And so we get negative 2 to the negative first power is equal to 1 plus c3. And negative 2 to the negative first power is just negative reciprocal of 2, 1 plus c3. If I subtract 1 to both sides, we end up getting negative 1.5 is equal to c3, and therefore negative y to the negative first power equals x, minus 1.5 is your particular solution. And I mean, it looks kind of funny, and if you want to clean it up or make it look nicer, you can, but you don't have to unless they ask for a certain form, as we're going to see in example 2. So notice in example 2, they want us to find the general solution, but they want it in the form of y equals, right? So notice in our first example, we're not in the form y equals. We're pretty close, but not quite. And so for this example 2, we're going to need to put it into y equals form because they asked for it. All right, so step 1, we're going to do separation of variables. I'm going to multiply by dx on both sides. And I'm going to multiply by 1 over y to cancel out the y's. So I'm left with 1 over y dy is equal to x dx. Fantastic. Let's take the integral, and we end up getting the natural log of the absolute value of y plus c1 is equal to 1/2 x squared plus c2. We're going to subtract our c's from one another, so we get ln of y is equal to 1/2 x squared plus c3. Do you guys notice at this point that we keep doing the same thing? So in the end, you just technically have to add one constant to one side and you're all set. Okay. All right, so this problem, we need to get it into y equals form. So we have a natural log of y. I don't know if you guys remember how to solve this problem from your pre-calc days, but basically what you can do is I can make this equation go from have a base of e to all of the equation that we have. Okay. Now what that does is this whole thing ends up just turning into y, which is nice because when you have e to the natural log power of anything, the e and the natural log will cancel out. Okay, and we can talk about that idea at another time. But you'll get y is equal to e to the 1/2 x squared plus c3. Now I need to talk about a different algebra concept. So let's say we have 2 to the 3rd power times 2 to the 4th power. We know that can turn into, from our exponent properties, 2 to the 3 plus 4 power, right? And we can go backwards or forwards. So notice what we have. We have here, we have a base, and we have two exponents that are added together. A base and two exponents that are added together. So what we can do is turn this right one into e to the 1/2 x squared times e to the c3. Just like how if we have two exponents added together, we can separate it by separating the bases and have them multiply. So that multiply. Okay. So what's nice about that is that you get y is equal to e to the 1/2 x squared. And now what is e to a constant? Isn't it just another constant, right? So our ultimate solution becomes y equals c, some constant, times e to the 1/2 x squared is your general solution. Okay, now I would put a big star on this problem because this idea, all the steps that we just took from the natural log all the way down to our general solution, we are going to see this over and over again. So I would star this part and rewatch it, re-understand it, and make sure we get it. Okay, we're moving on to our next example 3 and 4. So example 3, here we go. We're looking for a particular solution. So let's separate our variables. I'm going to multiply by dt. So we get x e to the negative t dx is equal to dt. And I'm going to multiply by e to the t, which will cancel this and this. So we get x dx equals e to the t dt. We're going to take our integral to get 1/2 x squared is equal to the integral of e to the something is just itself and plus some constant. Now I'm just going to write it as just c on the right side because if you looked at our previous problems, notice that when we have constants on both sides, we end up adding or combining them and always getting a constant on one of the sides anyway. There's one right there. If you look at example 2, same thing. Constant 1, constant 2. If I subtract the constant 1, I end up with a constant on the right side. Okay, so basically the pattern says that we're always going to end up with a constant on one side. Okay, so we're looking for a particular solution, so why don't we plug in our condition here at this time. So we end up with 1/2 1 squared minus or equals e to the 0 plus c. And let's solve for this. This just becomes 1/2. This is equal to 1, and there's c. So c ends up equaling negative 1/2. And so our final particular solution is like so. Yep, there we go. Let's find example 4, our general solution. Separate our variables, keep the dy, gonna multiply by dx. I want x's on the right side, and I don't want the y there, so I'm going to multiply by y. So I get y dy is equal to 1 plus x over x dx. Okay, so let's take the integral, both sides. I'm going to clean up the right side a bit by dividing the x and distributing it. So it's going to be the integral of 1 over x plus 1 dx, which is a lot nicer. Take the integral, 1/2 y squared is equal to the natural log of the absolute value of x plus c. And there you go. That is your general solution. Pretty simple. All right, there you go.